Today we'll start out our lesson by doing some converting, practicing the tracks one more time. So I'd like you to work through these 6 problems, seeing how you can use the tracks to help you out. I'll probably talk about a few of them, and then you'll need to just pause this so that you can work the rest of the problems and then turn it back on to check what your answers are. Okay, let's do just a couple of them together. The first one with 5,000 inches into feet. Your tracks, you would go 5,000 inches. Nothing on the bottom here. Okay, so we will put 12 inches is the same as 1 foot. The inches cancel, so we'll be in feet. When I multiply across the top, I get 5,000. Multiply on the bottom, there's really not anything to multiply. So 5,000 divided by 12. To the nearest hundredth would be 416.67. Okay, the next fact is your kilograms and pounds. I handed out a conversion fact sheet today. If you don't have one, try and find your pink sheet from the state test review. It has some conversion facts on it. Otherwise, I will put one of these copies in eBackpack so that you can access it there. Okay, with the 250 kilograms into 1 pound, again setting up tracks, we have 250 kilograms. I forgot my 0. 250 kilograms. Okay, nothing on the bottom. Okay, on my kilograms and pound conversion, it says 1 kilogram is 2.2 pounds. So 1 kilogram is 2.2 pounds. Kilograms will cancel. So again, it's a multiply. 250 times 2.2 is 550. Notice the denominator is just 1. So when I divide by 1, it doesn't change it. 550 pounds. I'll do number 3 with you and then leave you on your own. Okay, for number 3, we have 20 miles. We want to change it into kilometers. On my conversions, I see 1 kilometer is 0.62 miles. 1 kilometer is 0.62 miles. So I'll put the 0.62 miles on the bottom. 1 kilometer goes on the top so that the miles will cancel. So the calculation that I need to do, 20 times 1 is 20, divided by 0.62. 20 divided by 0.62, rounded, is 32.26 kilometers. Okay, so there's 3 examples for you. You do problems 4, 5, and 6, then after you have worked them, turn this back on to see if you got the answers right. Okay, shut this off. Okay, if you have worked the problems, let me show you what the answers should be. So there are your final answers. On 4, you would have used the fact that 100 centimeters is 1 meter. On number 5, you would use 1 inch equals 2.54 centimeters. And on number 6, you would have used 4 quarts is 1 gallon. All right, so after the practice of conversions, then we went to lesson 7.6, and we'll talk about scale drawings. So we're going to make pictures today. You'll probably need to pause this so that you can get written down everything that you want. But a scale for a scale drawing indicates the ratio of the drawing measurement compared to the real life measurement. So you need to make sure that you have this relationship. When we talk about a scale for a scale drawing, the measurement on the top of the fraction is the drawing measurement. The measurement on the bottom is the real life measurement. Keep track of what units there are as you work these. It says a scale ratio or scale factor is the number by which each dimension of the original object is multiplied to find the corresponding dimension of the model. You can multiply to find our answers today. I'm going to take the approach that matches with our chapter. So I'm going to be setting these up in a proportion so that then you can cross multiply in order to find the measurement that you need. So keep in mind I'm doing the method just for our chapter. Scales can be expressed with or without units. It says a scale of 1 to 4 would mean that the drawing that you make is 1/4 of the original size of the real object. Since there are no units, the 1/4 can be used in a lot of different ways. It could be 1 inch on the drawing is 4 inches in real life. 1 foot on the drawing is 4 feet on the real object. 1 millimeter is equal to 4 millimeters. So you can use all kinds of units on the 1 to 4 or the 1 to 100. When you get to 1 inch and 1 foot, you cannot use that with like centimeters or with millimeters. It has to be inches and feet. So if you have some other measurements, you have to convert those into inches and feet in order to use that scale. 1/2 inch to 50 miles, that might be something you'd see on a map that would help you figure out the mileage in between towns, for instance. So scales like 1 to 8, that's going to make a reduction drawing. It's going to be 1/8 of the size that the real object is. So it reduces it down. If you have a scale like 3 to 1, you're going to enlarge whatever it is. 3 to 1 would make the drawing 3 times as big as the real object. Now, in what situation would you be drawing a bigger picture? Well, it might be that you're drawing what you see in the microscope in science class, or it might be enlarging a piece of jewelry to show the details that are in there. So something that's small that you need to look at in a bigger format. So scales could go either way. All right, we're going to try and practice some conversions or calculations so that you can make some simple scale drawings on the worksheet that is your assignment today. It says use a 1/16 scale to draw a 36-inch tall lamp. What's the height of the lamp for the drawing? Okay, we're going to do the proportion method. So when we do the proportion method, you will always start with the scale factor. Notice there are no specified units. So we can make it apply to anything that we're doing. Okay, 16 inches, is that the drawing of the lamp or is that the real life actual lamp? Since it's a real life actual lamp, the 36 inches will go on the bottom, and the top is what we're looking for. We're looking for how many inches to draw the lamp on our drawing. So to cross multiply, we get 1 times 36 equals 16 times x. Divide by 16. And that comes out, grab my trusty calculator, 36 divided by 16, 2.25. So what's that mean? Well, our units, based on the fact that the 36 was in inches and this is in the same fraction, my x will be inches. Do you recognize the decimal 0.25? If so, great. It's 2 1/4 inches. That's how tall you would draw the lamp when you make the scale drawing. Now, if you don't know that 2 1/4 inches is the same as 2.25, maybe we need to go back and instead of putting this answer in decimal, Let's go in fraction. 16 times 2 is 32, so there would be 4/16 left. 4/16 reduces to be 1/4. So you could work it just in fractions rather than in decimals. Okay, so we figured out that we would draw a 2 1/4 inch tall lamp using the 1/16 scale and the 36-inch real-life measurement. So look at that fraction set up, the proportion that I have. That's how you'll be doing a lot of the problems today. Okay, the next sample, I changed the scale. It says make a scale drawing of the classroom floor, so just a rectangle that's going to represent the floor. 1/32 is the scale. Now a floor is going to have a length and a width. On that last one, I just gave you the height of the lamp. I didn't give you two different numbers. So right here we have two measurements that we have to work with. So when we do our scale, we're going to have two problems. I'm going to ignore the 30 feet right now and just work with the 24 feet measurement the first time. So to do our proportion, 1/32 equals how much over 24 feet? If we cross multiply this, we'll be drawing in feet. I'm guessing that we probably need to look at it in inches rather than feet because of the size of like a sheet of paper. It's not going to be a lot of feet. So let's go to inches instead. So let's change it. 1/32 equals how many inches over, let's convert now. Let's make the 24 into how many inches it is. That's part of why we're doing conversions. 24 feet, converting, 1 foot is 12 inches. When we multiply 24 times 12, we get 288 inches. So let's replace the 24 feet with 288 inches and then cross multiply. That way our drawing measurement will be in inches. Okay, so cross multiply. 1 times 288. So 288 equals 32 times x. Divide by 32. And we get 9. Now since we changed the units, when we do this drawing, it's going to be 9 inches. That's just one side of the rectangle that we need to draw to represent the floor. So we're not done, but we know one direction is 9 inches. So I'll go back to the 30 feet up here. So this time I'm going to ignore the 24 feet because we just worked with that one. So I'm going to do the same steps with the 24 feet, or excuse me, 30 feet. We're going to convert it into inches and then set it up in our proportion to solve. Okay, I need some more space here. 30 feet. Okay, so 1/32, that's the scale. Is how many inches over, okay, I want 30 feet in inches. Well, it looks like I would just multiply 12 times 30, so 360 inches. That's what I'm going to use instead of 30 feet. 360 inches. Cross multiply. 360 equals 32x. 360 divided by 32, 11.25. I recognize that as a 11 1/4. Now, if you don't recognize it, then you need to back up a little bit. 11 1/4 inches is my second answer here. If you didn't recognize that, then go back to 360 30 seconds. It goes in there 11 times. 11 times 32, that takes care of 352. but I had 360 30 seconds. So take off the 352, and that leaves 8. So 8 30 seconds in fraction form. Dividing that, or reducing it, dividing both by 8 would be 1/4. So there's another way to think through the 11 and 1/4. All right, so let's go back to our original problem. What did it say to do? I think it said make a drawing of a classroom floor using a 1/32 scale. Okay, so we ended up with our rectangle needs to be 9 inches by 11 and 1/4 inches. So now you need a ruler. And so you will actually measure 9 inches, and then this direction, or it could be the other way, 11 and 1/4 inch. So finish making the rectangle. So this is a top view of the floor. And spell floor right. Floor. Now perhaps we would continue and make rectangles for all the desks and the chairs. On your worksheet, you're going to be doing like a bed and a table beside it, or a desk and a chair beside it. So there will be more than one thing that you are putting on the same picture. Okay, let's go to another example. Okay, it'd be a good idea for you to stop the video, try this problem, and then see if you did it right. Looks like I do have feet in there. So one thing you're going to want to do is convert the 4 feet and the 2.5 feet into how many inches they are, and then use the inches in your cross product calculation. Okay, so pause me, give it some work, and then turn this back on. Okay, the 2 conversions you should have done. 1/32 equals x over, let's do it in inches. So let's see, 4 feet into inches. Should have been 48 inches. So put 48 inches. Cross multiply. I know there's multiple steps here. Cross multiply. 48 equals 32x. Divide by 32. I think it is 1.5. 1.5 or 1.5 inches. Now let's do the 2.5 feet. Scale 2.5 feet in inches. 2.5 times 12 is 30. So we want this to say 30 inches so that we get inches on the drawing. Cross multiplying. $30 divided by 32. Now if you do that in a decimal, you're going to get 0.9375. Do you recognize that as what fraction it is? That's not a real common decimal. So let's not go decimal. Let's just go back and reduce this fraction, dividing by 2. So we get 15/16 of an inch for x. So a desk is supposed to go in that classroom. It's going to be 1.5 inches by 5/16. So I'm going to go back to my picture and just give you an idea of what to do. So in this floor, we're going to put a desk somewhere. And that desk, I remember 15/16. 1 and I think it was 1/2 inch. So actually measure, looking at my 9 inches and that, I I don't think I drew that to scale very good. Let's go a lot smaller. I'm just randomly drawing it up here. If that's 9 inches, then it's probably going to be more like this. A lot smaller than what I originally drew. Let me see if I use the right measurements. At 1.5 and 15/16. So you made a classroom floor and you put a desk or a table in there. Now I think I have one more part where you are going to put a chair beside the desk. This chair is square, measures 1 foot 10 inches in each direction. So let's have you figure out with the scale of 1 to 32, how big should the chair be that's going to sit beside the desk? How many inches is 1 foot 10 inches? I don't know if I want to write that in tracks for you or not. 1 foot is how many inches? 12 plus 10 more. So we should have 22 total inches. Cross multiplying. Divide. I'm going to just do this one in fractions. 11/16 inch is what X is. That said, this chair is square. So the chair is going to be 11/16 of an inch by 11/16 of an inch. So going back to our picture, again, I should have probably used a ruler, but beside the desk, whichever side you have room on, draw a chair, and each measurement on that chair should be 11/16 of an inch each direction. So you have a floor, a desk, and a chair. Right chair inside there, I guess. I don't have much room. But label so that I know what's going on. Okay. If you don't recognize the decimals, you can go through dividing and see what all the decimals are here. Or as I mentioned in the lesson, go to fractions and reduce the fractions rather than going to a decimal. These are the fractions that you would have on an inch side of your ruler. I have the decimals up to a certain point. You keep filling out the chart if you need that to look at. Okay, that's all for today's lesson. We did some other things at the beginning of class as our bell ringer, but this was the main part of the lesson.